Good. You should be ready. People are saying to thumbs up the stream before we started the stream. That's getting a little ahead of things, don't you think? This could be terrible. This could be awful. You don't know. You may want to, like, I guess you can always reverse your thumbs up and make it a thumbs down.
That makes me sad. Please don't thumbs down. That will make me sad.
What if we're terrible? Don't we then deserve it?
Then we deserve nothing.
That just
ambivalence, there with like
just like meh.
Thousands of views and no thumbs in any direction.
That sends a powerful message to us. Time to say hello. Now's your chance. The hello inning. Where is Pamela? And why are you on the phone? People want to know. Is this not important to you? Should I just get on my phone too? Is this how we do Astronomy Cast now?
So here's the thing. I love you all, and I wanted you to have quality audio. Because really, that's the most important thing of this. You don't want to be seeing my explosive hair. You want my voice. And I'm currently in a hotel near Dulles Airport for a large meeting. And our Wi-Fi is horrible. And if I tried to talk to you using my computer, it would not work. Or it would work, but
no. This is it. This is the way. What matters is audio, not necessarily video. And so in this case, your phone call into our Zoom meeting is working great. And then Pamela's recording locally with her Zoom recorder. So, in fact, as your explosive hair is actually, being captured quite well so far. So don't worry about it. We both get your explosive hair.
That's because you have no audio.
And acceptable audio. And the podcast listeners, they'll never even know what happened.
It's true.
So I'm going to say hi to some people. Hello to Arnold Post, Adam Synergy, Astro B, Brian Stab, Colin Jones, Frank Tippin, Guido Bibra, Henrik Bo Anderson, Holly Meyer, Hugo Burnham, John Seifel, Johnny Zed, Just Looking, Quad Libet, Magnus Themer Jensen, Nichols of the Yard, Noel Ruppenthal, Ren and C Brazil. Congratulations, Noel. Scott Grise, Sean Harlow, Truck Captain Stumpy, and Zappan. Hey, everybody. Welcome to an episode of Astronomy Cast. Now, if you have no idea what did I say Graham Walberts? I think you showed up there. Anyway, if you have no idea what this is, what you've stumbled into, especially if you're like watching my YouTube channel and you want to know what this whole Astronomy Cast thing is, we are going to record an episode of Astronomy Cast, episode 466, The Origins of Zero. And then we'll wrap that up, and we will stick around. I don't know whether we'll stick around and answer your questions about space and astronomy. We will see how Pamela's time and Wi-Fi holds up. We didn't negotiate that beforehand, so I don't know what you want to do, Pamela.
Time is fine. I think Wi-Fi is going to be the real consideration.
Okay, all right. Well, we'll see what happens. But your time is okay.
Yeah.
Okay, right. And can you say what you're doing?
It's everyone who has the kind of funding from NASA that I have to fund CosmoQuest had to attend a meeting in Washington, D.C. This is to better facilitate collaboration across all the different funding groups so that we don't have duplication of efforts. So it's basically a meeting that has nothing worth tweeting about, where we work on doing good in non-scientific ways that allows us to do the science later.
This is great. Someone mentioned
I'm a bureaucrat sometimes.
Yeah, well, even when you're literally phoning it in, you're doing awesome, says the chat, which I think that's great. All right, let me know when you're ready to press record. Remember, you got to press it twice.
Oh, thank you for saying that. Okay, I'm pressing it once. My levels look okay. I'm pressing it twice, and the numbers are going.
Perfect.
Okay.
All right, and I'm going to press record as well. All right, here we go. Astronomy Cast, episode 466, The Origins of Zero. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today. With me is Dr. Pamela, the Director of Technology and Citizen Science at the Astronomical Society of the Pacific, and the Director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you?
Good, and you are calling in from the country's capital. Your country's capital.
I am. Yes, my country capital. It's far warmer than yours, I think, right now. I'm near Dulles Airport at a meeting location for a collaboration meeting for everyone who receives the kind of funding that I get from NASA that is basically designed to allow us to better collaborate, keep up to date on what we're all doing, and find ways to prevent duplication of effort and spread the effort better across all of us.
Perfect. And if you sound a little different, that's because you're recording on your portable audio device that's sitting in front of you from your hotel Wi-Fi. This is us being incredibly flexible to make this episode happen. So I'm really glad you were able to find some time, to sneak in some time to be able to make this happen. We depend on zero for our math to work right, but this number was actually invented in fairly recent times. Why do we need zero? Was it inevitable? Pamela, zero. Zero feels like one of those things that is just like part of math, like it's woven into the fabric of the cosmos. There's the middle point between the positive numbers and the negative numbers, but it's not.
Well, so if you want to be literal about it, in the Mayan not making way of recording accounting, it's literally not a knot.
It's not a knot. What?
So one of the ways that the Mayans recorded numbers, and you just like stumbled into this and gave me the best opening ever, is they would actually do accounting on ropes by tying specific kinds of knots, and the way that they recorded a zero was to not have a knot there.
Got it. So it was a knot. But they didn't know in ancient Mayan civilization that knot and knot would be the same sounding word used hundreds of years hence in the English language. Man.
Unless there is a time-traveling punster. I'm really hoping for a time-traveling punster.
Right, okay. But this is just one example of a civilization coming up with this concept of zero. And that's not the only one. Like people have come up with it multiple times separately, kind of like animals figuring out how to fly, right? Or eyes or things like that.
And they have had to come up with the concept of zero in multiple different ways. So for instance, with the exception of the Egyptians, who were weird and had hieroglyphs for everything, most systems of numbering are based something. So here in English language, using Latin alphabet and the algebra that you and I both learned in school, we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it starts over 11, 12. And these
I've got the computer graphics. I've got the computer science background, so I just count 0, 1, 0, 1, 1, 0, 0, 1, 1. That's all I know.
I don't believe you. Plus, if you were a true computer scientist, you'd work in hexadecimal.
Whoa, thrown down. Now I still need a calculator to convert my hexadecimal into my binary code. So hold on. I actually learned binary code. It's funny to totally rabbit hole here. I learned binary code when I was a little kid. Someone taught me that you could count to 32 on just with one hand. And so I learned, so you like put out your hand and you like you bring down one pinky, right? And that's 1, and then you bring down your next finger, and that's 2, and then you bring down your pinky again, and that's 3, 4, 5, 6, 7, 7, 8, etc. And so you can actually count up in binary code on your hand. And I ended up like using that when I need to calculate. So I still sometimes have to calculate with binary code. I use my hands.
I think you just explained to me how valved instruments work in a way that finally made sense.
If they've like had turned valved instruments into binary code, yeah, you could probably write it in binary code, and that would make a ton of sense. Anyway, I totally rabbit holed this conversation. Let's go back to talking about the development of zero.
Okay, so you need zero for three different positions. What I was starting to say is if you work in a base 10, a base 8, a base 20, whatever base you work on, it turns out that when you repeat, you are periodically going to have a nothing. So for instance, you have a situation where your nothing occurs. So, for instance, with 10, it goes 1, 0. And so what do you do when you have 104 of something? You have the ones digit, you have nothing in the tens digit, and then you have 4 in the ones. So it's 1 in the hundreds, 0 in the tens, 4 in the ones. And this combination, what do you do if you don't have the concept of zero? So one of the original things that happened was they just basically put flashes there, angled flashes. And these 2 angled flashes denoted there's nada in this placeholder. But that is a different concept than the concept of nothing zero, or the transition from negative amounts to positive amounts, which you start to need when you get into algebra and deficit accounting, which we should all be probably avoiding, and most of us probably aren't, especially as we enter the giving season.
So, before we go any further, Chad, you may want to cut this out. Remember that the device that is recording your audio is not your phone.
Yes, that's true.
So
that's
you are terrible mic control right now. Great for your phone. Yeah. But not for the video recorder that's in front of you. So I just want to remind you to think about where the audio is going.
Stay leaning forward.
Yeah. But it's great. It's hilarious to see you talking on the phone. Because clearly that's where your brain is going. Is you're literally moving around. And you're like and the way you're talking to me is like you're talking on the phone, which is so funny. All right. So okay. So. Why do we need zero? It was developed by the Egyptians. It was developed by the Mayans. It was developed, the Greeks had their own version of it. The classic one that we use. The
Babylonians.
The Chinese, the classic one that we use today is the one that was developed in the Middle East, right, by Islamic mathematicians. So it was clearly this idea that needed to happen. What do we need it for?
So to go back to that placeholder reference, you're doing accounting tables, and you're keeping columns of numbers. And some poor slob is reading along later, trying to figure out how many chickens did you have? And the way you wrote 104 is 1 in the hundreds column, nothing at all, just a blank space in that tens column, which is what they were initially doing, and then a 4 in that one space. Now, the problem is this poor slob who's trying to deal with this stuff later, he doesn't know if you goofed and forgot to write something down or you meant you had nothing. And so that ambiguity is the kind of thing that breaks accountants and mathematicians and actuarials and all of these people who are really worried about all the numbers being right. And for early math, it was accounting and actuarial work. You had to know how many people you were collecting taxes from. It was that where it really mattered. And there's a difference between 194 chickens, if you forgot to write the 9 down,
right,
and 104 chickens. And so this is where that initial just slash stab it into your cuneiform was actually quite useful.
So they would put, so just to understand, so they would put like a 1 for the one number, and then whatever is the ancient Sumerian digit for 9, they would do that because they were still using base 10 as well, right? But they would put like to show that it's a null digit. It's not one of the 10 digits or one of the 9 digits. It's a not digit, but don't forget it.
Right. And so this is coming from the Babylonians, and it was just basically we need something to shove in here to mean this placeholdery place has no values in it.
So that's one reason why we need a 0.
That is one very good reason we need a 0. Now, the Egyptians, who weren't big on base anything or having a written language that was based in an alphabet, they apparently like to make it as hard as absolutely possible to be literate. And in order to do this, the way they denoted 0 was it had its own symbol, but so did every single other number. So you had number upon number upon number. This is basically the way they refer to it is these are not positional. It's just a whole series of 1, 2, 3 is a set of symbols, 13, 14, 15 set of symbols, not related to one another. You can see no resemblance between 4, 14, and 104. But these were architects. These were people who were very worried about geometry and measuring positions. And so they're the ones that came up with that concept of 0 as that place that you're measuring your base from, that ground level, that zero truth. And so they had the concept of 0. They had the symbol for it. What they were missing was the positional concept. So you have the Babylonians, who are actually the ones who gave us that whole crazy hours, minutes, days, hours, minutes, seconds system. So they were working in sexagesimal just to make life evil.
Right, like base 60, like turning...
Yeah.
Which is crazy. I mean, to have a circle be broken up into 360 degrees and to have hours, like obviously, have hours be broken up into some number, but have that broken up into minutes and seconds, but also measuring. So that's all the Babylonians' fault?
Yes. Yes, it is. Now, the Egyptians, who did work in base 10, but didn't have positional math, instead had these unique symbols to make it really hard to be literate, but made very pretty writing. Their very beautiful system had the start here, this is where there is a nothing value. And what's cool is the symbol that they used actually also meant beautiful. So they considered nothing beautiful, which if you don't pause and leave a beat there, has a completely different meaning. But to them, that concept of nothing was a beautiful thing. And that's cool.
Yeah. So the Egyptians were using 0 to try and help them with their, obviously, pyramids and whatever it is they were building. The Babylonians were very concerned about making sure they got all their taxes in so that they could fund their enormous armies and conquer the nearby lands. Who else was working on 0?
Well, it was one of these things that cropped up just about everywhere in different ways. So we had them working on things in the essentially thousands BC. And what gets me is we always raise up the Greeks as the great architecture of modern culture. And so you have the Babylonians working in 2nd millennia BC. You have the Egyptians working about the same time in 2nd millennia BC. flash forward to classical antiquity, by which I mean sometime after Christ. And you have the Greeks getting into a philosophical argument and existential crisis over zero. Because they didn't want to say that there was something, and by naming it, it became a thing.
That was nothing.
Yes.
Right.
Yes. So you have this horrible mental stopping point in the years after Christ, where they just basically had a mental breakdown over but it's a thing if we give it the name, but it's a nothing. And for 2,000 years, no one had issues in written documentation. Both the Babylonians and Egyptians appear to have gotten the concept of zero from other societies. This was not a new idea, but the Greeks had to have a mental breakdown over it because this is what the philosophical classical Greeks did when you left them alone.
Right. So they resisted and, maybe considered the Platonic ideal symbols for nothing, of nothingness.
Yeah, Ptolemy is one of the ones who actually wrote a lot on this. He was using a symbol for zero that he had borrowed from the Babylonians. He needed in his mathematical works, which is how we ended up with the Babylonian sexagesimal system for basically all of astronomy. But yes, the people in general, this was a problem.
Okay. Who next? Because I think we're moving towards, time-wise, our sort of more modern concept in the more modern societies. So sort of what was another big development in zero?
So Fibonacci, who is by far one of my favorite, and I feel like such a nerd having a favorite ancient person who worked in the sciences. Fibonacci, who's one of my favorite ancient mathematicians and scientists. He's one of the ones that came up with the realization that we had all of these different mathematical series that described all of these different spiral shapes and everything. He's starting to get into the post-Charlemagne era of Europe, where it was now Italy rather than Rome. And he's responsible for basically the word zero that we currently have.
Really? I didn't know that.
Yes. So it is stolen from other terms. What I particularly like is you may have heard basically the hot air balloons that were called zephyrs, which comes from old roots of Zephyrus, which is the west wind. And the concept of zero is a bastardization of that idea of that nothing, that wind. And it's out of the Venusian way of speaking that this got turned into zero.
But when did we really see like that first zero, the shape?
So the first shape of zero, it goes back much further, because it's, if you look at it and you look at the Greek concept of theta, all of these were coming out at about the same time. Again, blame Ptolemy. Blaming Ptolemy seems to be a fairly common thing to do.
Don't we already blame him for messing up the solar system?
Well, he was trying to do right by many things. He just didn't always succeed.
Yeah. But I mean, a lot of the math, I was mentioning this earlier on in the show, that a lot of the mathematics that we do today, a lot of that came from a lot of the Arabic mathematicians, especially a lot of the best astronomy came out of that, out of that area. And they had a big hand in zero too, right?
And one of the things that really was sort of like brain breaking that I came across while preparing for this episode, there's a really cool book that is written from kind of like a first person passion project called Finding Zero, a Mathematician's Odyssey. And it's one of those things that goes through and discusses all of the how do you track down the origins, and this includes like looking on the sides of pyramids and digging through jungles. And in a process of looking into the origins of numbers, it was realized that we often refer to our current numbering system as the Arabic Hindi system, but Arabic numbers today and Hindi numbers today look totally different. So the symbols that we're using, it's a living system. Alphabets, the way we use them, the way they look, they all change over time. And so modern Arabic, ancient Arabic, the intellectual bias towards getting at the root of things has been fairly constant in the culture, but the way the numbers look have evolved. And I just think that that's so cool.
Right.
Sorry, random rabbit hole.
No. We're free to rabbit hole. What was that book again that you mentioned? Finding Zero. What was it called?
It's Finding Zero: A Mathematician's Odyssey to Uncover the Origins of Numbers. It's by Amir Akzel, Aczel. I may be pronouncing that horribly wrong. It exists both in Kindle, which is how I got it, and there's also an audio version. I recommend the Kindle because there are symbols and pictures and diagrams, and I don't want to think about what happened turning those into audio. And I love audiobooks. Get this one on Kindle or paper. Paper's the thing.
So when have we sort of stabilized on our modern thinking of zero?
So our modern ideas really started to percolate out during that Greek classic period. And while the philosophers were having existential crises over giving a name to something that was nothing, the mathematicians were like, we need this. We're just going to use it and move on. And by about the 5th century, it was just sort of okay, we're good. We've got nothing. Literally zero. They had nothing.
We had nothing. And so then from that point on, we've sort of been using that modern interpretation of zero. Now, you mentioned sort of earlier on, and we were talking about this before the show, that you were sort of running through the reasons we need zero, and we sort of glossed over them a bit. We talked about that you need a zero as a placeholder, but really, what job is zero doing in our mathematics?
So mathematically, you need zero to be that thing that is between having something and having a lack of something. And the way to think about that is, on payday, I have something in my bank account, and hopefully a zero on my credit cards in a perfect world that I don't think has ever actually existed, but this is a goal. By the day before my next paycheck, I have significantly less in my bank account, and I have possibly an amount on my credit card that indicates a total amount of less than zero. And I'm just talking about day to day. I actually have like retirement savings. No one worry about my future out there. So you need to be able to say when somebody owes you money, you need to have this concept of negative. When you have less than the average amount of water in a lake, you need to be able to have that concept of negative. And to go from the negative numbers to the positive numbers, you have to have that point that is neither negative nor positive. And zero is that point that is neither a something or a lack of something. It is a nothing.
Right, and the
So,
key being that it is a one, it is an integer like 1, 2, 3, 4, 5, and that it is that halfway point between 1 and -1, that as you're counting from one to the other, if you don't have that 0, if you just go from 1 to -1, your math is all messed up.
and this is really a concept that was worked on a great deal in the 7th century in India. So India is another nation that has an amazingly rich history of advancing algebra, of advancing mathematics as a theoretical framework, as well as an applied subject. And so it is really amazing, all of these different nations that we don't learn about in school that are actually the reason that we have science. It's because they were advancing the math.
And were there 3? Did I miss one? There was you need a placeholder. You need that sort of halfway point between positive and negative.
And you also just need to be able to denote that there's a nothing, that thing that gave the Greeks an existential crisis.
Right.
So you need a 0 to say, I currently have 0 French fries. This is a true statement.
Yes. An existential crisis.
Yes, it is.
Yeah.
And so to be able to express that lack of French fries, I need 0. Now, if I had 12 French fries, I don't need a 0. But if instead I had skinny little shoestring French fries cut into little pieces, and it turned out that I had 206 of them because I was being a French fry eating crazy person, I need the 0 as a placeholder. Now, if I had a small child who, and I don't, who was like, fries, give me fries, I could say, I owe you a plate of 30 fries, which requires a placeholder, and you will get it if you behave for the duration of this recording. So say I'm speaking to an imaginary child that does not exist. I could have a deficit of 30 fries that I must somehow come up with in order to get that imaginary child to be quiet for the entirety of this episode. Again, I do not have said imaginary child.
No. I understand. It's possible that I have run those kinds of scenarios in reality.
Yes, I believe this is where I learned these scenarios.
So, but the, one of the things that's very interesting about 0, and we deal with this all the time in computers, is the divide by 0. That's where that's where 0 really makes our lives miserable, when that 0 ends up on the, as the denominator of a fraction.
And this is something that is a new break everything of the digital age, where you have to do numerical approximations to continuous functions. By which I mean, if you ever used logo in school, you knew that the way you drew a circle was you moved one step forward, tilted 1 degree sideways, moved 1 step forward. And so you approximated drawing a circle by making a polygon of 360 sides. And that is an approximation of a continuous function. A actual circle is a continuous function with infinitely small steps between each movement forward, using that cosine and sine. Now, with computers, they can't handle continuous functions. They can't handle the mathematical concept of infinity. And so this is another place where, again, existential crisis related to a number, because how do you have a word for a thing you can never actually have, but yet we seem to actually like the idea of the universe being infinite is an idea. It could exist. the idea of there being infinite steps between me and my webcam if I keep dividing the distance in half. Now, the reality is I'll eventually bang my nose on my webcam. But computers can't deal with this concept of infinity. They can deal with the concept of zero, and both are needed to have continuous functions.
Right on. All right, we're out of time. Thanks, Pamela. We'll talk to you next week.
Okay, my pleasure.
Your gambit totally paid off. There was a bunch of times where you went totally static on the screen, but the audio just kept going. So, good call.
Yeah. I realized it was. I did a webcon the other evening, and it was just like this is not working. And I like you guys, and so I was going to find a solution, and I did.
So I'm supposed to shamelessly promote something. Let me just get this thing in front of me here. I'm going to hold up a book. Here we go. So check this
I know
out.
What you're going to show.
Here, let me see. I'll hold up the book. 101 Things to See in the Night Sky. I've got a copy of it.
It's only 100 things. You're adding one too many. It has 2
100 things.
Zeros.
Not. It should have been 101 things. When we talk, which we're about to, I'm going to suggest that. So, 100 things to see in the night sky. Should have been 101. What are you going to do? So we're doing another book giveaway, this time in conjunction with Dean, the author, joining us on the November 29th episode of the Weekly Space Hangout. So the Weekly Space Hangout crew, not me, not Pamela, the crew is giving away 2 copies of this book, which hits the stores on November 28th. So to win, send an email to giveaways at wshcrew.space with the subject 100 things. Include your name and email address in the body of your message. To be eligible, your entry must be postmarked no later than 11:59 p.m. Eastern Standard Time on Monday, November 27th, 2017. 2 winners will be selected at random by me during the Weekly Space Hangout. And you don't need to be watching to win. And it's open to all viewers worldwide. 1 entry per person.
Excellent.
Yeah. So if you haven't already, send email 100 things to giveaways at wshcrew.space. Of course, the Weekly Space Hangout crew, this is the community of fans that supports and really helps produce a lot of the shows that we do through CosmoQuest. So they help us with the Weekly Space Hangout, of course. Man, amazing guests coming in the next little while. I get to talk to Andy Weir again, the author of The Martian and now his new book, Artemis, which is apparently coming my way. We've had a chance to talk to pretty big muckety-mucks in NASA. So it's just been amazing. So if you want to be part of this, if you want to take your fandom of space and astronomy to the next level, join the WSH crew. Go to wshcrew.space. And it's all free, and there's lots of instructions on what to do. And then you too can be an executive producer of what we're doing. All right, so let's get on to some of the questions that people have. Let's go. Now, there's a question. Remember, it doesn't have to be about what we just talked about. Could be anything. Noel's wondering if we can do an episode about calculus. Different kinds, where they come from, what are they for? What do you think?
Do you not like this anymore, Noel?
Do you have to, or did you have to teach any calculus, or were you teaching physics that required calculus?
I taught calculus-based physics, and I'm happy to do calculus-based physics, but going into the history of the different kinds of calculus is a special journey into the land of Eastern European names that are easy to confuse with one another, and crazy theoretical physics stuff that all eventually became relativity. So I think we're better off talking about the physics than the calculus. One is a tool.
There is a great battle between Newton and was it Gauss? Who was best? It was two.
Lemaitre.
Lemaitre were battling over who had developed calculus first. So, and of course, you get into a fight with Isaac Newton, and everybody ends up bleeding. So, because he was apparently not a very nice person. All right. This is a great question. It comes from Arjone. Is math part of the universe or a fantastic approximation that we made up? Is math a fundamental feature of the universe, or is it just the way human beings cope with it?
I think it's the way human beings cope with it. So like the way I always explain constants that we have in physics is, so for instance, the force of gravity is described as the gravitational constant times the mass of the first object times the mass of the second object divided by the vectorial separation between the objects. And that G is because the universe does not work in the metric system. And so we keep ending up with all of these constants because there is no universal base 10, there is no universal mathematical system. A lot of times we end up resorting to the speed of light is 1, and we do all sorts of math that way just because it's easier. But it really feels to me that mathematics is a tool we have developed to describe the universe that we're within, and that fundamentally it's like assembly is to computers. It's the language we use to communicate with the physics.
And we've brought this up as an example in the past, like white holes, for example, as an example where the math works. If you set, and I forget the exact thing, is that if you set the size, I believe it's the size of the black hole, or something. If you set the event horizon as some certain arbitrary thing, then you get what is a white hole. And it's not like it actually exists, just that the math checks out.
Allows it.
Yeah. And so you can have all kinds of things, all kinds of theories where the math works, but it doesn't mean that the thing is real. And you can have other examples where the thing is real, but the math fails to fully explain and comprehensively describe what's going on. So,
but what's beautiful about it, and also makes me very grateful that I'm not a mathematician, is you can describe a physical reality that is not our own, that does not exist, that is internally completely consistent, using different forms of geometry, using all these different building blocks that are just a variation on our own. So through math, we're able to envision alternative realities in an internally consistent way that maybe in a multiverse might exist, but in this universe don't. And that's cool. It's cool. I don't want to do it.
Sylvan West
cool.
is asking if we can do an episode about the math in stellar Magneto Hydrodynamics.
We can. So are you talking about the 5 fundamental equations that control stars?
No. The movements of magnetic fields through the plasma generated upper atmosphere of the star. The hardest math that there pretty much is.
I didn't hear the word magneto. I just heard hydrodynamics. I'm like, that's easy. Yeah. I can do that. But
Magneto Hydrodynamics, which I believe you described as the worst math out there that there is.
Especially if there's dust involved.
Right.
Let me talk to someone who actually does that for a living and see if he'd be interested on either going on the weekly space hangout or on one of our office hours to talk about it, because me talking about it is liable to lead to mathematical blasphemy.
Right. But I think the joke that Sylvan was making was that you have in the past described stellar Magneto Hydrodynamics as the ugliest math, and only the most masochistic of astrophysicists take this on.
The ugliest math is string theory, but that's not provable, whereas Magneto Hydrodynamics is.
Right. That you can do observations of the sun and see if your Magneto Hydrodynamic theories match the reality of the sun's behavior. Let me see.
How many screens are you using?
4.
I love your system. I need to know what arms you're using at some point.
It's a PWR Plus. I got it from Amazon. It's got 4.
Is it set for 4? Yeah, okay.
Yeah, so it's got 4 arms that come out, and then I've got 4 identical BenQ 21-inch monitors. They're all cheap monitors. It's so crazy, right? Like, to make a setup like this, and I need to have the setup for doing the broadcasting because I have to put your feed on one monitor, I have to put the Slack on another monitor, I have to put the control software for running the Hangout or running the live stream on another monitor, and then have the actual what it looks like in another monitor. So 4 is like the minimum what I need to be able to produce these shows. And in fact, there's
and I've been doing it with one normal monitor and one extra wide, and I'm thinking I need to change my symmetries.
Yeah, and it's not that expensive. It's funny, like, you know, the monitors I think were like $120 or something like that, and then the arms was like $50. So, you know, it cost me about as much as like a nice 4K monitor to have. And I don't even care if the quality of the monitors is garbage. I just need to be able to have the room to be able to spread everything out and construct the show. So, so there's a couple of people are talking about the idea of resonance as an episode. We should wait, if we haven't done an episode on resonance. Yeah, I was just thinking about that, and then we absolutely should. So let me just search one more time just to make sure. We've done a lot of episodes.
There's some really cool resonances I don't think we've talked about that I learned about when I worked at Harvard. So, for instance, if you hit someone, I want to say it's somewhere between 5 and 15 hertz. If you hit someone with a sound wave with this really low frequency, you can make them puke.
Is that like different from the brown note?
Yes, yes, but same concept.
But you make them nauseous.
The brown note. Yeah.
Right. That's amazing. But like so I'm doing some writing on planetary migration right now, and one of the things that's really interesting about planetary migration is you get these planets. They, you know, the way the orbital mechanics works is, as if a planet forms within this disk of material, it's going to be throwing material out. And as it does, it's going to be losing orbital momentum and drifting inward as it goes. And it will eventually run out of material and then stop and get into this orbit. And then the next planet out will take the same journey moving through its disk, and when it hits like a 2-1 resonance, it will stop. That put the brakes on it. So now you got the first planet going once around or twice around. You got the next planet going once around, and so these outer planets will all follow this resonance as they all sort of drift inward and tighten up to get that resonance in a perfect system. Our own.
And what I love.
Oh, I was going to say, but in our own solar system, because there was enough mayhem going on, they could never get that resonance, and in fact, they spread outwards, and Neptune and Uranus flipped places, and Uranus got knocked on its side, and so Jupiter pretty much did make the right movement to the right position, but the rest of them just couldn't sort of complete the journey because there's too much other stuff going on in the solar system. So this idea of resonance is really powerful and really helps explain where the shape and structure of our solar system and all those other extrasolar ones. Whew.
And what I love is I spent my entire week in administrative meetings. And so you say resonance, and the first thing I think about is the right frequency will make somebody puke. You spend your entire week working on careful, nice science communications, reading the science papers, and you go straight to the Nice model. So it shows that environment affects where we go.
Well, we always note that, you know, you're the one with the astronomy background and I'm the one with the computer science background, and somehow we seem to spend more time in each other's domains, which is funny. But yeah. So Noel's saying that we did planetary migration in 301, and that definitely would cover some of orbital resonance, but I think there's more resonance as well in terms of breaking of, shattering various kinds of materials, and there's also the resonances.
Lasers.
Yeah. So I think there's a lot to be said for resonance. So I don't know. Do you have a plan for next week? Do you want to do resonance next week?
Next week we may need to take off because I'm going to Disney World and Disneyland and Universal Studios, as this is how I got myself through a week of meetings.
Right. Okay. Well, whatever. I'm putting it on the list. You're on notice.
It can be what we record next.
Okay. Yeah.
What I learn when I go to these meetings is I truly am an introvert, because after 2 days of meetings, I just have to keep like some sort of an internal mantra to keep extroverting.
Arjun wants to know, will quantum computers be able to do any math that would help solve some astronomical problems?
Yes, globular clusters.
Explain how.
So all of the three-body problems that can't be solved any way other than numerical step after numerical step. This is the kind of thing where the first petaflop computer ever built was built to handle globular cluster modeling. And to be able to run all the calculations simultaneously is kind of awesome. And that's just like what came to my mind, because that's something that I'm interested in. I'm sure there's far cooler things that just don't happen to be things that are like my pet part of astronomy.
Right, but where quantum computers work best is when you've got to perform some kind of really complicated calculation, and the quantum theory will let you essentially solve this simultaneously, and it'll just output the right answer across all of the sort of calculation space, which is just amazing. Larry Beckham wants to know if we've covered the Pamela, the payload for antimatter, matter exploration, and light nuclei astrophysics. Is that it? That's an instrument on board something, isn't it?
Yeah, there's And no, we haven't.
What is that on board? The Pamela detector attached to the Resurs DK1. What? So like a German satellite? Weird. It was a commercial Earth observation satellite operated by, it's a Russian? Interesting.
I think Italian, or there's multiple things that have my name related to space.
That's awesome. All right. Any other questions anyone has?
Yeah, it flew on Russian, but it's Italian.
Okay. Can you defrost? Truck Captain Stumpy wants to know if you can defrost a turkey with deep cord or plastic explosives. I don't think so.
I wouldn't try. You're likely to get a lot of charred charcoaly meat, which will be a higher carcinogen.
So here's a question.
And please be careful, any of you who fry your turkeys.
Here's a question from Ryan Schmitz. Could the expansion of cosmic voids in the universe be tied somehow to continuous collapse and condensation of diffuse materials in regions dominated by gravity? Did you catch that question? So
I didn't parse the question.
So could the cosmic voids in the universe be caused by collapse and condensation of materials in those regions thanks to gravity?
If things are condensing and collapsing, I'm not sure why the voids would be expanding.
The voids are coming from the things moving apart from each other thanks to the expansion of the universe.
Right. So that's the walls.
Yeah.
So, and actually they would do that without the expansion of the universe. So you don't need if the expansion stopped right now, you would continue to get the collapsing of the walls and the superclusters and the clusters and the merging of them. So the voids appearing to expand as the density of the walls and Maxis becomes higher and things pull in. The way to think of it is not as the voids expanding, as the material of the universe condensing into tighter and tighter lace patterns. And it's not that you have an expanding void when human beings all decide to rush a ticket counter. It's that all the humans are rushing the ticket counter, and you're ending up with an overdensity at the ticket counter. Now, the way you get an expanding void is if you have a whole bunch of police officers with police tape forcibly making a void in the center of the humans. That's an expanding void as compared to a condensing wall. So we have condensing walls that appear as expanding voids.
All right, I got one last question from Jordan Couch. Will there be a time in the future that we, humanity, understands everything there is about the universe?
That would be awful boring. I hope not.
You hope we always have questions. And whether it's not humanity, but or, our robot.
Intelligent life, whatever format it might take, I hope always has questions to drive it forward. And luckily, that question may someday be, why the heck are all of these weird things buried here? Or luckily, you can look backwards to have questions as well as you can look outwards and look into the future.
But if you turn all of the universe into computronium, if you essentially make as much thinking atoms as you can in the entire universe, it will have a certain amount of computational capability, and it will max out at the level of computations that it will be able to run through before it runs out of energy, won't it? Like, won't there be an ultimate limit to computing, and then that will define the number of clock cycles that you're going to get before the end of computing, at the end of thinking?
So I can imagine that there's a limit on how many calculations can be done before the universe ends.
Yeah.
But the question is that ultimate number of times you can answer a question sufficient to answer all the questions? Or
right.
So the way a farmer puts it is, there's always going to be chores to do, so why hurry? You're going to die with things undone anyway.
Yeah, my dad always says, house finish, man die.
Yes.
So there was another question. Nope, I lost it. Never mind.
Okay.
Oh, okay. Right. So this is just people are talking about seeing space launches, and that go to Cocoa Beach to watch any Cape Canaveral launches. And I just want to sort of second that recommendation, which is, if you think it's hard to go see a rocket launch, it's not.
No.
It really isn't. That if you go to out to Florida, go to Cocoa Beach, which is really nice place to stay, lots of great hotels. Yeah. You can go down onto the beach at Cocoa Beach, and you can watch rockets take off, and they are almost as good. When I saw, we actually went out and we got to watch the OSIRIS-REx launch, and we got to go right out to Cape Canaveral, and we got to go out onto the launch way and watch the rocket take off. But being out in Cocoa Beach and seeing the rocket get prepared, it wasn't that much closer from where we were, and I'm sure, watching that rocket go off. So if you ever want to see a rocket launch, if this is in any way on your bucket list, go to Cocoa Beach.
Just go do it.
Just go do it. Yeah, when a launch is happening.
Time it.
Yeah, yeah. And even if you're within, if I lived within, I don't know, a day's drive, then I would drive down for when the launch is going to happen. Find a place to watch it from. Watch the rocket launch. Drive home. Like it doesn't have to be that difficult of a bucket list item to knock off. So that's just my recommendation. If it's something you want to do, make a plan to go do that. It's like going and seeing the Milky Way or watching a meteor shower. Like, it's not, even if you live in fairly light polluted area, it's worth doing. And
plan the launch to be the first day you get there in case it gets delayed, so you still have a couple of days of forgiveness.
Yes.
And this is another reason to always drive is plan for 3 or 4 days. If it launches on time, maybe go home early, maybe go down to Disney World, enjoy yourself. And clearly I had Mickey on the mind.
Clearly, you're going to have fun. All right. Well, thanks, Pamela, for joining us. Thanks to everybody in the chat and over on the WSH crew for being part of this broadcast. I have no idea when our next episode is, so stay tuned. We will put it on the calendar when we know what's going on. Thanks, everybody.